Hello, my Flat Earth family. This is Marilyn's Spirit Level, and I'm doing a reply video. Oh, but of course I have to pick a piece of the video where I have something going into my mouth, which is just ridiculous. Anyway, so I had this meetup planned for last Sunday, the 20th, in Quakertown at the Proper Brewing Company, and there was a terrible weather forecast, so I think nobody kind of put it on their schedule. After this, I did have one guy call me as I left the building on my way home. I got a phone call, and here he was on his way. He says, "Sorry, I'm late." I'm there. "Well, that's okay. I just left, but I'll turn around and come back." So I went back for half an hour and had a meet up with him. But so I was sitting there with my table display, and from Flat Earth 101, it's a tiny little banner, 9 by 15 and inches, that is. And this young man comes walking in, and he says, "Oh, well, you know, I was expecting, you know, a meetup." I said, "Well, this is it." And we had a conversation, and he tells me his name is Charles, and he's from Norristown, and he's a math teacher. And I assumed it was Norristown School District, although the websites, it is very difficult to find the staff roster. I looked, but I'm not going to spend all day. I'm just going to tell you what he said, and you can take it from there. So he does have a channel, and his channel name is Flat Earth Math. Yeah, Flat Earth Math. Now, why wouldn't you call it something like, I don't know, Earth Math, Flatter Globe? I don't know. It just seemed a little bit, because it's really not true math that we would use, that the Flat Earth community uses. So, now, yeah, you're saying that math should all be the same. Okay, but wait till you see what Charles does with the math that he uses. Like with all globe believers, you cannot nail them down with a nail and a hammer at all. They are all over the place. They do not want to answer a direct question. And it's all based on something obscure that you know, and you'll see that I tried to get him to come to some logical understanding between us that, you know, there can be a way of determining curvature or not curvature. But like with him, I find the same thing with all globalists. They do not want to go there. So these are the kinds of conversations. If I was out and I had my banners out on the street or on the boardwalk or whatever, I would have quickly assessed this man as a globalist, and I would have asked him to move on, because I was not going to try and convince him. He was already convinced. So you don't do that. You don't waste your time on someone who has already decided. They have an agenda. They love the world they live in, and they don't want it to change for whatever reason. It could be lots of reasons. So don't even waste your time. You are taking it away from someone who may have an inclination to be an honest evaluator of the evidence. And I had found that Charles does not evaluate evidence at all. So, this is, as you can see, math teacher 1 out of 2. It's not 1/2. It's 1 out of 2. So there is 2 parts to these videos, and you have them on both of my channels. So, okay, let me see what he talked about. He said he was in the Flat Earth debate since 2008. So that's 10 years. And for all that time, he has never wavered. He has never really studied flat earth. From what I am understanding, he has never studied flat earth. He has made assumptions, which I am going to point out. And his assumptions are giving him some erroneous mathematical hypotheses that he is following. And so I think we need to, like, this is a good exercise in evaluating people and you know, do they have motives? And right off the bat, he talks about shill. So, you know, you think, well, why is he talking about shill? All right, so he's putting me on guard that I'm not supposed to call him a shill. That's what I'm evaluating from that. You know, it's people who want to, and I'm not saying he's a manipulator, although, but people who want to manipulate you right away will put you on the defensive, and in a way that you will not want to assign that label or that definition to them. So, like, they'll come out with a sad story, you know, and say, oh, well, you know, they'll make you think that they're a victim of some sort of circumstance. And so you don't want to doubt their word. You will know that you will be offending them if you say certain things. And so when you see somebody like this, I'm going to let him talk a lot. And you're going to say, well, Marilyn, why didn't you straighten his behind out? Okay, why didn't you hit him with this or hit him with that? Well, I had an opportunity here to try and get him to say what was really in his mind, and I think he has tripped himself up because there was a couple of times where he contradicted himself. So these are good exercises. When you have an opportunity to look at this, watch him. Watch what he's saying and how he's saying it. And every time I brought up something, did you notice how he went into a long, I'll say explanation, because I don't need to be derogatory, but he automatically took the route. And he loved this angle. This angle that he was talking about was when there's an object at a distance, the angle is less, and he's talking about refraction and all. And these are all things that are not necessarily definitive. So, okay, he talked about the virtual dome. And he finally got down to minute 14. He marked the shadows on the equinox. So let me see if I can get that. Minute 14. See if we can get that.
And this is me trying to figure it out.
Oh, I'm sorry. I'm sorry I did that. You know where I went? When I disappeared there for a minute, I was so annoyed with the speaker that was right behind us in the corner. We were sitting in the corner. I did not want the music playing. We had asked if they could turn it down. They could not. I got a chair and I went up and I unplugged the speaker. And I saw nothing wrong with that. No one else was in that listening area. It was just us sitting there. So I just unplugged the speaker. And then afterwards, I plugged it back in. So I was perfectly willing to accept responsibility for that. I did no harm at all. I didn't even leave dust on the chair that I stood on. So, okay. Let me see if I have, yeah, I'm going to turn this way up. There we go.
Made no sense. And this is me trying to figure it out myself. and it's making no sense to me, that the shadows would predicted to be in a straight line on the equinox. It's like, but we've all seen the videos of the shadows being curved, you know, it's like, but it would be a straight line. So it's like, all right, well, let's test it. And so I went out on the equinox and I marked the shadows for 12 hours. Well, it wasn't 12 hours. It was from when the sun was behind the trees or whatever. So it was as much as I could.
Okay, he said something there. As predicted, the sun's shadows would be in a straight line. Okay, so if you look at the globe and how it has the Cancer, Tropic of Cancer, the equator, and the Tropic of Capricorn, you will notice that they are only in straight lines when you are perpendicular and directly on them. When you are not directly on them, they are curved. When you have that and you turn the globe, yeah, they're curved. So it depends on where you're standing. If you're directly on the line, okay. But no. So those things, I'm not exactly sure how they were derived. And I'm wondering something, because we do see slightly different than what we are shown. So this is something about perspective that needs to be studied, and how you study these things, like why is that way? So you have to do some study. You can't just be haphazard about this. Okay. Now I'm going to go and show you his, let me see. This is his experiment. And here he is. It's called, down here, Flat Earth Experiments 4 out of 15, Path of the Sun. Now, I did not go all over his channel and look at everything. I did not see his data in this video. And this is pretty much all I'm going to do, unless he comes back and says, oh, well, here's my data. Okay, well, that's fine. But I'm still going to have to get my own data, and I'm going to have to look at it. Now, this is what he is showing, and it shows why it's curved that way. Why it's curved opposite from the flat Earth AE map, Gleason's map. Okay, so he put the gnomon where we are, and in the United States is right behind here. As you can see, there's Mexico. So he's saying that he took this map, and look, right over here you can see this is his little flashlight. So he took his flashlight and he moved it across, following that where the Cancer and equator and on the map. And this is how the shadows mapped out. But look what he's doing. He's doing it on a map. And he's doing it with a flashlight. And he also made the assumption that okay, at 48, let me see if that's on here.
3,000 miles altitude above the equator and tropics, centered at the North Pole.
So, here we go. This is his assumptions.
Observing the sun for further guidance.
Number 4
Fortunately,
we're doing.
In this experiment, we won't be looking at the sun, but rather marking shadows. Here's a quick overview. We're going to record the path of the sun throughout the day using a simple shadow stick sundial. The flat Earth model says the sun moves in a circle at 3,000 miles altitude above the equator and tropics, centered at the North Pole. This will produce a pattern of shadows that will be a semicircle. The globe Earth model says the sun path moves around the Earth.
Okay. So what we're concerned about is what he's assuming with the flat Earth model, and that is incorrect. Not all people say that the sun is 3,000 miles above the plane. I do use the flat Earth map because that's the best one that we have so far. But I do not say that the sun is 3,000 miles above. Now, the other thing is, he is not, when he is showing, well, we can play it.
Producing a hyperbolic pattern of shadows. Supplies.
All right.
We'll
that
make
gets
a simple shadow stick out of...
That gets a little, he did a really good method of setting it up, giving instructions. It's like to a high school class, well, even elementary class, actually. Getting the clay, making the stick, you know, having a logbook. Well, that's, you know, that's all very nice. Putting the compass markings on it, okay. He said at least 5 times throughout the day. I would think you should do more. Snap a photo. All these things are nice and very good. He set that up very nicely. I want to get right down here to, you can find the center of rotation. That's fine. And he shows about the it being opposite because of the pinhole camera. He goes into predicted zenith angle. Let me see. Analysis of results. Okay. This is the flat earth that he's showing. Okay, and we kind of, I teach that, yes, but not the 3,000 elevation. I don't teach that. Although it could. I don't have an exact number for that. So let's see what else he's doing. This is the reverse of the pinhole. That's understood. And you can go over that if you'd like. You can watch his. But this is more of like, how do we figure out when somebody is making a mistake? Flat, all distance on map, not necessarily scale analysis. Sun's path doesn't require exact distances. Well, that's true. Okay, then here he has it set up. And there he's taken these measurements. Okay. Now the big problem, the very big problem is he's holding his sun 3,000 miles above this map, right? No. In fact, we all know when you're outside, there are times of the day when your shadow's longer and times of the day when your shadow's very short. In fact, if you were directly under the sun, there wouldn't be a shadow. You'd be standing on yourself. So, this I am saying is totally in error. Because when the sun comes up, and it does not come up, we in the flat earth, no, it does not come up. It only appears to come up. So it comes into view. It breaks the darkness. It breaks the horizon. I'm sorry, it breaks the horizon because it does get light before you see the sun. So it breaks the horizon and it is very, very low. It is on the plane visually. So it appears to be coming up, but we know it doesn't. So it is very, very low. When something is very low, you get a very long shadow. So at sunrise, you're going to have a very, very long shadow. And then as it gets higher in the sky, it's going to get shorter. So noon is the shortest shadow. And then it goes and gets longer again. So this is at error. This is totally at error. And this was one of the things I said to him at the end of the second interview. I said, you need to do more, or at least some, reality field trips. You need to do reality. And he's not doing reality. He's only doing theory. And he's taking some tools, but these are only representations of what we think it could be like, but we can't represent or replicate the sun coming up. How can that be done? So you have to be outside and you have to do this yourself. So did he provide his data? No, he did not. He's giving, like, well, what he thinks it could be. And he thinks it's going to be like this. Even though, look at the equator. Is this the equator here? This is a line. Look how that goes. So why isn't, I mean, it should be the opposite of that, don't you think? So this is definitely false. This is an error. A real, I'm going to say this a couple of times. I'll say it now and later. A real scientist will take the data and conclude from that without expected results. It's almost as though he's trying to make this fit. And so it's almost mocking, which I totally object to people mocking. And when he was there that day, he said, oh, we're having a nice civil conversation. Well, were we really having a conversation? So this is something else. Whenever I call this more of an interview trying to find out what he's thinking about and where his mind is at. So when you're in an interview, it's a totally different set of circumstances than a debate. When you're in a debate, you have one person giving their evidence, and then the other person is allowed the same amount of time to refute that evidence. And then the original person has a very short time to give a follow-up. So that's how they set up debates. It's one, then the other. One, then the other. So it's not one person asking a question and then this guy talking for a long time and saying the same things. Do you understand this? So you've got to, there are no online debates that I know of because it's very difficult to have a moderator who tells the one guy who talks all the time to stop talking. And this is why they will never subject themselves to a debate, because they don't want to be held to a time limit, because one of their great weapons is being able to talk and use words that confound and confuse. They can make up a word that nobody knows the definition of, and they can use it in several ways, and they can make someone else confused. But that's not getting to the truth. And they only do this by being able to speak as long as they want, and they repeat and repeat and repeat. And then they think they've, as long as you don't tell them they're full of crap, then they think they've won, when that's not true at all. And this is what's very nice about this, the videos. Now we can put this into a format where we can evaluate it and refute it after the fact. So I did not feel bad at all when he left that day. I was there just trying to figure out who this guy was. From what I understand, he's been around a while. He said himself since 2008, but I hadn't known anything about him at all. I didn't watch any of his videos. I didn't hear about him. I don't know. I had no knowledge of this guy, and he just shows up. Okay. So he had these predictions, and the comments I have on his, he said on his video, I'm going to make some comments here. He said, be very careful about observing the sun. Follow the guidelines. Well, I guess as a teacher, he has to say those things because of liability reasons. If any of his students want to do this experiment, then, and they gaze up at the sun and, they come in seeing, spots in front of their eyes, they'll, the parents will get mad at him. So, it's a liability thing. He's in a position of authority, So, yeah, I guess they have to be careful and give all sorts of disclaimers. But I have done sun gazing myself. So there is some safe ways to sun gaze, and I recommend it. I think it's wonderful. So you should look up sun gazing, and, you know, first off, start slow. Do it for short periods of time, and when the sun is low on the horizon, when it's in orange, and it's going through the atmosphere because it's filtered. It's definitely filtered. So then it's weaker. But I don't think there's anything wrong with looking at the sun. But you have to be responsible. Okay. All right, the only difference in the pattern is the width from Cancer to Capricorn. Okay. He goes through the flat earth model. The model has false premises. When science does not match reality, then it ceases to be scientific. And I say that all the time. Your science has to match reality, or it's not science. And his science here definitely is not matching reality. Where am I? Oh, minute 13, I have something written down. Okay, let me see if I can get to minute 13. Let's see what he says at minute 13.
Part C, Geometric Analysis. In this model, the path of the sun and how it relates to the shadow of our gnomon throughout the day is a bit more complicated, so we'll have to use some more geometry to get it right.
The gnomon is the stick in the middle. He says, all right, let me play.
The globe Earth model has the sun about 93 million.
Now, you do see that this is 50% of their globe is illuminated by the sun. You do see that. I question that, if that's legitimate or not, even with the globe model, because their sun is 93 million miles, and I think he shows that. I hope he shows it right away.
And the Earth's counterclockwise rotation gives us night and day. This extreme distance to the sun is about 11,000 times the Earth's diameter.
Now, if this were true, don't you think that the outer edge, since the sun's rays are coming out at all different angles, they're coming this way and straight there, and don't you think that some of these rays would hit the back, further back of the Earth than just halfway? Wouldn't they wrap around farther? I'm just thinking that, you know, just halfway, that's all they will go? Because these rays come directly out. Well, the ones that we're concerned with, because they do go out this way too. They do go out that way and that, all directions, up, down. So, but the ones from the edge towards the Earth, wouldn't they wrap around the back and go further than 50%? You can comment, make a comment to what do you think about that. Okay, let me play a little bit more and see if we can get to this next thing.
So in terms of the Earth-Sun relationship, the Earth can be considered to be a single point. If the globe Earth were the size of a basketball, the sun would be a gymnasium about 2 miles away.
Yeah. Okay, the thing I have here is the sun size would illuminate more than half the Earth. Okay, good. Then he goes on to D. Now, we've all seen this. This is still part of his C section here. That's funny. Section C. And Yeah, this is equinox is this side and this side. And this would be summer, our summer, and this would be our winter. Okay? So, and in these go up before they go back down. And this appears to go down before it goes back up. So that would be the opposite on the shadow things. But that's only if you're at the equinox. There's something, now wait a minute, there's something, is, I don't have the data on this. I don't really have the data on this. So I'm going to be more observant as to what's really happening. It appears to me when I'm outside that the sun does go away from me. I'm in the northern hemisphere. Most of us are. Hemisphere, hemiplane, north side of Cancer. That's what I am. Okay, let's see if see what's happening here. Now he's showing that this is really the path of the sun. These red lines are the path of the sun. So this is what I'm going to show you. There's a, when you type in flat earth, oh, I don't have that card with me. I'm sorry. But flatearth101.com/begin. Right up here you can see it. flatearth101.com/begin. So if you type that in, you will get 3 videos. The first one you'll get, this is what you'll get. The first one you get is the 200 proofs. And he has embedded this in there. Dave has embedded this in, so we always get the correct version. There are some tampered with versions out there, so just be careful. The second one I felt was very important because, look, he put this on here. It was designed by me. Okay, so the second one I put on here was the shrinking sunlight. It's the time lapse of the sun. Now, this is not the original guy. Jordan is not the original guy, but this was his, I think it was P-Brain. Yes, because I remember his voice on here. But this, I like this version. So, P-Brain, I'm sorry if you have this exact version. Give me the link. We'll switch it out. I like to use original stuff. So, please don't be offended. P-Brain has done some good work. Although, I wish he had a different name because I couldn't use his name. People would look at that. They would look, oh, P-Brain, what does this mean? Are you making fun of me? Are you mocking me? And so I had to explain that like twice. I'm there, oh, see, I had to change that out because you don't have time to explain all this stuff. When you're out on the street, you just got to go boom, boom, and here's the information. Now go look it up. But if somebody's going to question that and think that they're being mocked, oh my gosh, you can't take that. And it really cuts into what you're trying to tell them. So we can't have any negativity or any mockery going on. I am so against mockery. So when we have, this is such a wonderful video. Look, there's P-Brain. This is such a wonderful video. It's 18 minutes. And there's so many good things in here. I really hope you all go look at it.
Maybe the Earth is flat after all. And maybe it's completely still, just like we experience.
See, but we have to experience it. That's what he's saying. You experience it. I love this. Love this. Look. There it goes.
Come on.
And look down here.
That's all perspective. That's, if you look at jet trails.
Look at that light. It reflected off the water in here.
They start out low at the horizon. They come up overhead. Look at that thing. They come up overhead, and then they go down to the horizon.
It's so exciting.
Explains what the sun would do.
So exciting to see this.
I love time lapse. Look at this.
I love it too, P-Brain.
You can't see this stuff, except that it's on, time lapse like this. It's incredible. Now watch this thing. It's sweeping. The sun over flat Earth is doing a big circle, right? Look at this thing. See it sweeping to the right. It's like a lefty bowler. Just toss that down the alley, and there it goes, hooking into the pocket.
Oh, love that. Don't you just love that? I mean, it gives me the chills. Just gives me the chills. There's something else back here that gives me the chills, too. Of course, that's a wide-angle lens there. Oh, here it is.
This is how I would do it if the sun were 93 million miles away. Just like that. Have the whole horizon light up and then fade evenly across the whole horizon. But that's not what we see.
That's not what we see, is it? Watch it again. It's a cool animation, yeah. NASA's really good at their animations.
Okay, wow, look at that. Look how the light lifts off the ground like a big wedge or like lifting up a sheet of paper. That's incredible footage. Definitely the light's following the sun, right? Okay, next I'm going to show you how a sun that is circling over the Earth, that creates the horizontal aspect of the sun. If you combine that with perspective, which creates the up and down of the sun.
Okay, perspective, creating the up and down of the sun. Now, he'll get to this in here, and you must go watch these videos. If you have not already, you must school yourself, discipline yourself. You must study. I tell everybody 2 or 3 weeks I spent just on perspective because it's not what we were told. You have to unlearn it. You have to unbrainwash yourself, and you have to study and observe and get schooled in reality. So
the next 3 slides, I'm going to do a comparison side by side. The one on the left, the camera's above the clouds. The camera on the right is ground level.
Oh, look at these things. I'm telling you. There was one where he shows the diagram.
Well, how's that possible? I can see now you're saying that it rises and lowers due to perspective, but how does it disappear below the horizon?
He talks about...
I got a theory about that.
Diverging parallel lines, diverging perspective. Here.
They then separate, so the sun would continue on a downward track. As you can see from my illustration here, the lines would go to your horizon, and then afterwards they would spread out.
But where is the sun?
Like a starburst, and the starburst being at your horizon, at your
actual path of the sun. This is what is reality. This is what we see. That's the reality of our vision. The sunlight shrinks and follows the sun. This is what they put up in NASA, and this is what we see.
Anyway, without further ado,
look.
We're going to start talking about, and I'm going to start showing you the time. They then
sorry. That picture was really good. I wanted to show you that.
And illuminating.
But look, the sun is illuminating here. And look, you're getting that light coming down the bottom of the clouds, which are all at the same level. And look, the darkness is coming in from the sides. And I put this on my sunrise videos too. I pointed that out on my sunrise videos. You probably had seen that. But the darkness is closing in from the sides. It's just like a big blanket wrapping the sun. It's just so wonderful to see that. It is just wonderful. Look at it coming in. The shrinking sunlight follows the sun. Yeah. What else? Look at that sunlight disappearing. Look at that. That would not happen on a globe. That would not happen if the sun was that far away. Look, oh, look at that one. Gorgeous. So I recommend that you all watch this and study perspective. There is a lot of information out there on perspective. And watch it all, but then you know what? You have to be discerning. You have to be discerning. If something sounds a little wacky, put it on the side. And then look for more on that. And talk to some people who you think are knowledgeable in the subject. And then go and look in reality. Observe it for yourself. Please, 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 please. Thought there was something else I wanted to point out from that. Maybe I can come back to it. Here's the other one that I have on this. This is by Rob Skiba. I'm pretty sure he was the original one of this. But atmospheric magnification, refraction, and the movement of the sun over the flat earth. Well, Mr. Charles was talking about refraction a lot. Oh, look, Plane Ranger. Plane Ranger from the UK. This is one of my favorite pictures. And I use this in a lot of my stuff. Look. There's the horizon of the ocean, directly in line with that level. He's got a 6-foot level. Mine's only 4. But here, this one. This was really good in showing why the...
There is a lot of water in our atmosphere.
Yeah. And using that magnification page magnifier, you can show... Oh, how come it's not... There we go.
Entire Earth, land and ocean with 1 inch of rain. And, of course, goes on to talk about that as well.
So there's our Chicago.
Here, especially over water, is made up of zillions and zillions of tiny convex drops of water.
And there's some refraction.
Refraction causes the light to bend downward. Now, we've all seen pictures of, a pencil or something in a glass of water.
Yeah, and now, when he, this is what Charles was saying, that the refraction makes you able to see that because the light is bent downwards. Let me see if there was something else on here. Yeah, I'll show you that in a minute. But he was saying what Rob...
Downward.
Yeah, what Rob Skiba said right there. The light is bending downward so you can see it. Okay, so how come when Rob got in that boat and he held his camera on Chicago and they went across the water, nothing changed? So it was still there. It did not flip upside down. It was not... We could still see Chicago. You could see more of it the closer you got, but we could still see Chicago, and we should not have been able to. And then this Charles says to me, well, let's, when you say the word should, and somebody brought this up, it sounded like Clinton saying, I did not have sex with that woman, define the word is, right? I'm there, yeah, it kind of reminded me of that too, although I hate to think of Clinton in any way, but... that whole situation was horrible. But define the word should and come on now. At some point, Charles, you have to be a man. You have to say, I can see that or I can't see that. And when we have the P1000 camera, yes, I do have to admit there's something about this. I don't understand it. And at least when you come to say that, then you'll investigate more realistically. But you're not there yet. So let me go down here, and this is the experiment that he did. See, there's 3 views all at one time. See,
science is the same.
Moving it back.
Here's a simple example. The atmosphere.
There's
really
the camera,
like
and there's the close-up.
Yes.
Now here it's coming in. Now watch this. It's coming up. And look. And I actually did this. I took a long piece of cardboard, attached it to my tripod, and I did this experiment when I was in Jim Thorpe. So look up the Jim Thorpe videos and you'll see my experiment there. Although it is a little bit difficult to carry around, and it's you need the right area to set it up. And when there's a lot of people, like on the boardwalk, it is tough to funnel that many people through some information in order to get them over to looking at that. So it's not always a good circumstance to have those tools. So let me see if there was something else. Proof the sun does not illuminate half the globe. I got that. On the equator would... Okay. Sundials and their positions. You know, I do have a due east compass reading from a person in South Africa. And this is still perplexing to me. So I am going to continue to collect data on this. And see what we come up with. Back to his video here. Let me see if I have something on here that I didn't hit yet. I was trying to allow him to explain why he was so fixated on that angle. He kept telling me about this angle of an object in the distance, an angle. Well, okay. All we really need to know is that it does get visually smaller in the distance, although it's not small.